So welcome to the webinar 8 focused on supply chain management of the webinar series Data Science, Machine Learning and AI Applications and Opportunity. And as alluded by the topic, today's focus is on applications of AI, data science and machine learning in supply chain domain. We have a distinguished panel presented today, and I will first of all introduce both of them before we ask them to present and make their remarks. So the first panelist that we have today is Professor Manoj Kumar Tiwari, who is the Director, National Institute of Industrial Engineering, Mumbai from November 2019. And he was a professor with higher academic grade in the Department of Industrial and Systems Engineering at Indian Institute of Technology, Kharagpur, and currently on leave for 5 years, where he's serving as the director for NITIE. As a researcher, he is working on the domain of manufacturing systems and supply chain management. His research and teaching interests are in the modeling of manufacturing processes, operations analysis in supply chain network, optimization, simulation, and computational intelligence are main techniques adopted by Professor Tiwari to automate the decision support systems for complex and real or large-scale problems in manufacturing and logistics systems. His research interest has been supported by several industries, national and international research funding agency. He has published more than 320 papers and has an H index of 65 and more in the international journals of repute, and he has been rated as ranked 1 among top 100 individual researchers across the world who have published research articles in International Journal of Production Research during the time period 1985 to 2010. Okay, he's also mentioned as the top leading author in the domain of supply chain analytical techniques by Journal of Computer and Industrial Engineering, and he's also recipient of the most influential researcher award in the domain of operations and supply chain management. He's also recipient of Mahalanobis Distinguished Educator Award for the Operations Research Society of India in the category of management education, and is also listed among the top 20 most productive authors in the area of productions and operation management as reported in last 50 years. And more importantly, I also want to have a personal touch. He is also my undergraduate mentor and lifelong advisor who has supported me and educated me in last 20 years. The second second panelist that we have today is Dr. Alexandre Dolgui, who is an IISc fellow, and he's the distinguished professor, which means full professor of exceptional class in France and head of automation, production, and computer science department at the IMT Atlantique, which is formerly known as École des Mines de Nantes and Télécom Brigante, France. His research focuses on manufacturing line design, production planning, and supply chain optimization. His main results are based on the exact mathematical programming methods and their intelligent coupling with heuristics and meta-heuristic algorithms. He is co-author of 5 books, the co-editor of 20 books or conference proceedings, author of 266 referred journal papers, 4 prefaces of books, 30 editorials, and 37 book chapters, as well as 400 papers in different conference proceedings. He is editor-in-chief of the International Journal of Production Research, an area editor of Computers and Industrial Engineering, and past associate editor of International Journal of System Sciences, IEEE Transactions on Industrial Informatics, and the Omega International Journal of Management Science. He is also the consulting editor of International Journal of System Sciences and is advisory board member of various journals. He is member of more than 30 journal editorial boards, which includes a variety of journals in the domain of manufacturing and supply chain management. So with that, let's welcome both of the speakers, and I will ask and request the Professor Alexandre Dolgui to present and make his remark on today's webinar.
Thank you very much, Professor Rai, for this kind introduction. I will share with you my slides. Sorry. I would like to present to you our new European project, which was accepted some months ago by the European Commission for 3 years. It's a very large project on machine learning and decision support in manufacturing systems. I am coordinator of this project with the help of my two assistant professor, Simon Tebenin and Félicien Barreva. This project, the name of this project, Learning and Robust Decision Support System for Agile Manufacturing Environments. The name is Assistant. The funding obtained by from European Commission is 6 million euros for 3 years. This project was accepted following the call Artificial Intelligence for Manufacturing ICT 38. 72 proposals were submitted, only 5 were selected, and our proposal was ranking 2. What is the main idea of this project and the main participants? The current state of manufacturing production is characterized by the move from mass production to mass customization and now to mass individualization. So, new product is launched frequently. There is a large variety of product, a large assortment of product, and the customer lead time is shorter and shorter. So we need to produce quickly different types of product, and so we need some flexibility for the manufacturing system in the condition of large uncertainties on the demand and also on the environment. So the challenges is in control of production process, in the uncertainties, in design robust manufacturing systems and robust supply chain, taking into account the non-stable environment, and planning and real-time control of such system in these new conditions. There are more and more software in manufacturing system and supply chain. An explosion of data, many internal and external data. But existing systems are too far from current requirement of company, especially for assembly lines. What is the main case study in this project? Different assembly lines in different industry. There are some problems to design, process planning, design of line, selection of equipment, configuration, planning of production, production planning, scheduling, and real-time control. For very moved demand and environment with many data, we need to use to planify the production and in their uncertainty as close to as possible to demand. The current state of artificial intelligence application in manufacturing concerns low-level decision. For example, predictive quality, predict quality of product in system. The objective of assistant project is not the low-level decision, but the high-level decision, process planning, design stage, production planning, and scheduling. The decision should be data-driven, based on data-driven, and based on predictive and prescriptive analytics. Some idea of generative design for mechanical engineering is used to define the architecture of our systems. So the designer or decision makers in production obtain via visualization interface the result of optimization, and optimization is based on data, and then can guide the model, can change the parameters, can change the objectives to guide the decision support system, taking into account the preferences of user. Another idea of the project is explainable artificial intelligence. The models are based on mathematical model for decision aid. And the machine learning technique is used not only to learn the parameters of model, but to learn models, to obtain the models. By analyzing the data, we obtain all the constraints and the objectives of the model. This a new approach is in artificial intelligence, based on constraint programming, especially, and on our developed in our department technique of learning the model. To learn, we use the data in the manufacturing system, but also digital twins to generate new data. We have many data, but to have more data, we use also digital twin. Digital twin is used also to check some decision to help the decision maker, but in our system to generate missing data. So from sensor of assembly line, we read the data. We have ontology to exchange the data between subsystems. We automatically we design the digital twin. The digital twin generate new data to design optimization model for process planning, production planning, and scheduling and real-time control. Which can our objective is to increase the service level, product process quality, and productivity in the system. What is the concept of intelligent digital twin systems in our project? Intelligent digital twin, we will develop 4 digital twins. One by function, the first one for process planning, second one for production planning, the next one for scheduling, and for last for real-time control. All this digital twin will be interconnected and connected with sensor in physical process. The digital twin will be data-driven, self-adaptive, collaborative, explainable, and so on. We perceive from physical process. The next step, the information processing by using domain models, model acquisitions, learning by using technique of machine learning to learn model, to obtain model from data, generative design to communicate with decision maker and to find the reasoning decision and to explain to decision makers the solution by models, and verification of descriptive simulation, the solution obtained, and actuation of decision made in the real physical assembly line. The participants of this project, there is 12 participants, industry partners, Peugeot Citroën, Atlas Copco, Siemens, the organization in between academia and industry as Flandermake, and research institution Microsoft and research university, Technological University of Munich, laboratory automation control from Patras in Greece, UCC in Ireland, second university in Germany, Europe University, the Adrina, and of course the leader is IMT Atlantique, a coordinator of this project. TerraLab is this organization which create a data platform for enterprises. So this is the main line of this project. The project started at the beginning of this year, and we work now with case study. We have case study from Siemens, the assembly line for energy turbine, case study for Atlas Copco, this assembly line for air conditioning, and from Stellantis, this Peugeot Citroën assembly line for electric car in France. For each of these case study, we will develop digital twin for process planning and line design, digital twin for production planning to define the volume of production, and digital twin for scheduling, and digital twin for real-time control. All is based on machine learning of optimization models and parameters of this model. So thank you very much for your attention. I would like also use this occasion to say some word on IGPR. IGPR journal will celebrate this year 60th anniversary. For that, we organize some conference, 2 week virtual conference in France. Also next year it will be face-to-face conference also in France in June. I invite you to see the website of IGPR and all announcements on a call for a special issue dedicated to 60th anniversary. We place it the list the most cited paper in, published in IGPR on the website of journal. We can see recent most cited papers and special issue, call for paper for special issue, and so on. I invite you to submit to IGPR to celebrate this as the anniversary of journal. Thank you very much.
Thank you, Alexander, for your comments and regard. This seems like a very, very interesting project that you're involved in. We look forward to the results emanating from such a project that will be really, really beneficial, not only to the manufacturing, but in general, to people who are interested in data science, machine learning, and their application, not necessarily in traditional computer vision or computer science type of application, but more focused on engineering. So we'll look forward to your project, and I wish you all the best in your project. With that, let's move on to the second panelist, Professor Manoj Kumar Tiwari, for his presentation and his remark today.
So thank you, Professor Rahul, and my respect to Professor Alexandre and your team who is monitoring this webinar. And it's I think, very good opportunity you have given to me to talk something what we are doing with respect to the data science, particularly AI ML modeling side to the large audience of supply chain management and related things. Though there are hundreds of the models and applications are there, but we just focus on those which we have been addressing with some of the companies actually. So there we have some live example, but of course, because of NDA clause, we cannot disclose much. So all the data are morphed, but methodology and results are more or less the same what we have delivered. So with this note, actually, just I want to discuss my PPT before all of you, where all these applications are there in detail. Okay. So I think my slides are visible to all of you, Rahul.
Yes, we can see it's coming up. Yes.
Yeah. So basically, under the domain of this logistic analytics, we have been doing some work, and this we are presenting in your platform. As you can see, this logistic scenario in India is you can see that how much intervention it demands, that you can get clearly that at present it consumes around 14% of the GDP of India, and therefore we can save at least $50 billion if logistic cost reduces from 14% to 9% of GDP. And why I'm saying 99%, because you can see the most of the developed world, their cost range, logistic cost ranges in this particular domain. You can see that US 9.5%, Germany 8%, Japan 11%. And among them, if you see, the GDP share of different modes of transportation, like air, which handles mostly air cargoes, then water, that is shipping, then rail, actually, which contains all the petroleum products and other things, containers, etc. They are being traveled, and road, very large portion you can see in India from the road, correct? And here you can see that around 60% is roads here, and you can more rail is 32, air is around 1%, and waterway is around 7%. And freight models here in India, as you can see, there are two interesting projects which the government of India has started actually. Bharatmala and Sagarmala, they are two ambitious projects being undertaken by the government actually to improve the logistics in India. And you can see this global logistic market till now has touched around 6.9 trillion by 2026. And mostly thanks to the, you can say, ever jumping kind of e-commerce sector, which is basically responsible for this. So by this slide, what I want to prove that there is such a very good opportunity for the people working in the different domains of supply chain and logistics, that they have to contribute a lot to bring down and then save such a huge amount of cost actually in India. And then these are the two very important projects. A Bharatmala project, where is idea is to improvement in the efficiency of existing freight corridors. And then we have to build up the many multimodal logistic park where all the facilities will be there for internal transfers of the goods and services. And then many choke points which are there at the different roads and corners as well as the places, this we can eliminate. Because this is the city from where I belong, if you see that there are some boards, but near about that place, he used sometimes find a lot of choking, a lot of rush, a lot of traffic. So keeping that in mind, actually, this project has been designed, and the Sagarmala project is the vision of this project talks about total reducing logistic cost for the export-oriented items and import-oriented items, and then domestic trade both, and then minimal infrastructure investment that we are expecting from this. So keeping that in mind, the different zones and areas which are covered under this, basically they are all the coastal areas and little things where there are different ports, and then accordingly the major developments are going to take place in that side to avoid all these choking points as well as the promotion of the multimodal logistic parks. And each state government of the India has been asked and advised to have their logistics policy, and we are lucky to have formulated the same for one of the governments which are nearby to our place. And as you can see that for such things, there are many emerging issues are there, like say we call supply chain analytics, and then there are different components of that actually. As you can see that procurement is one of the problems of supply chain, where a lot of issues pertaining to the analyzing the supplier selection and then sourcing cost improvements, risk management in the sourcing. And recently you have seen because of this China crisis, a lot of talks are going on about near shoring kind of things, where recommendation is that in and around the consumption point, actually you have the major sourcing things. And that sort of things are also posing a lot of challenge before this global logistics scenarios. And then, as you can see, this manufacturing is one of the domain which requires this product R&D, then production planning and control, then quality management, maintenance and diagnosis. They are also being referred for many applications of the analytics techniques. And then warehousing, as you see that this is very interesting component of the logistics and a lot of space, and you can say share of the logistic warehousing is very high. And here right from the beginning, a lot of talks are going on that how the mixture of automation will take place, like how the robot, cart, cranes, they need to be automated actually, and they are all internal information systems need to be upgraded so that order picking, inventory control, and then RFID applications along with boating, which can make the warehouses to the next level. And a lot of projects of the very top companies are going on in that directions. And fortunately, one of the firms from you can say Hong Kong, there also some of my students are involved. And then logistics and transportation, as you can see, that here intelligent transportation systems, which basically based on the different information that we receive about the congestion, about the route planning, about the, you can say, the conditions of the road, along with the traffic that is there, traffic rate. You can decide the system, and also that how many consolidation points strategy you can design, and you can plan many things like how the different tolls and what you call places where the different state border meets. How can we make better arrangement for collection of the toll taxes without stopping of the vehicle at many places? So this is one of the very important thing, and a lot of efforts are going on to make the seamless driving. And then we also need a very big platforms where all the compliances like driver certifications and about the type of goods that you are carrying and security features in the goods, and which are being checked many times before the goods reach to the destination level. So I think with different compliance agencies and other, you can say, controlling bodies, there is a need to maintain a lot of transparent operations, and we need a very good digital dashboard to what you call link all sort of information on that. Of course, that's also part of big logistic planning actually. And then there are many in-transit inventory management systems where we have to design the, you can say, the cross-docking systems, or we have provisions of changing from bigger vehicle to smaller vehicles when you want to do the last mile delivery. And then demand forecasting, as you can see that earlier, I will cite an example that how much actually big contributions it can make to the managing overall business. So one such projects we are going to describe here in this line. As you can see that this analytics, which is now being well known, see what kind of arrangements are being managed by the many firms. If you can see clearly that this is the supply chain components, right from raw material supplier to supplier, then manufacturer, distributor, then systems of tracking, retailer, and you can say customers, and the kind of data you are collecting from all these different entities. They are in the form of reader, sensors, cameras, meter, robotic arm, QR code, RFID, then portable PCs, panel, barcoding, and this is part of data collection. Once data collection, then based on that, what are the different kind of information arrangement you are having, like say microwave station, then Wi-Fi access points, communication network, IoT gateways, and then small base stations. They are helped in transmitting the different kind of information to the entities. And from here, the moment you go to data analytics, then you find that from here, whatever data you are getting from different sources, they need to be cleaned, and then you have to integrate it, and finally, if needed, you have to compress it. So these are three options that people are doing for carrying out the operations. And then there are a distributed computing model. There are filing systems that how actually parallelly we are doing many operations. And then you have a fast storage, short-term storage, and long-term archival kind of data. And based on that, then only you go for the storage and computing on the clouds. So keeping all such things, then these are the four types of popular analytics being carried out, like descriptive analytics, diagnostic, predictive analytics, and prescriptive analytics. So most of the people are basically talking much on the predictive analytics, and then based on that, what the prescription through recommender systems they are giving, and diagnostics is well-known things that we are doing, and a lot of work you can see on descriptive analytics through the OR and other kind of models are being done. So here we are talking about a company which is situated near us, and they are supplying many sophisticated precision forging items, maybe from automobile to aircraft to many other defense applications. And they have at present around 600 to 700 different type of orders they are getting for around 400 parts, 400 type of what you call different type of parts that they make. And here they require different kind of raw materials like steel and ingot and cubes, etc. So you can see there are two very interesting things for meeting their order for their customers. They require different type of material type first. And in material type, there, you know, there are many ways that how does different other raw materials that they have to maintain the inventory actually. So there is one is material type and one is the raw material that they need. And then from here, you have to find out what is the, you can say their inventory that you are keeping for them for meeting the customer requirement. And from here again, based on the customer needs, you have to redesign the orders. And many times the suppliers of raw materials from the suppliers, as you can see, that we have to plan that in what way actually we have to keep the inventory for meeting all the 600 products so that there will not be overstocking, and also and there will not be shortage, as well as the resiliency at the company level can be maintained, and they should not face some sort of sorry figure that okay, we are not in position to meet this order. So in order to do that, actually we did a machine learning based analysis, and you can see here that these are the methods that we use. Some sort of things like, after analyzing their data for all the 662 material types, we found that based on the order data insights that we are having, you can see around 10.4% these orders material types are relatively high frequency requirement. Means they are ordered more frequently. Say for example, where we said 30 orders, correct? So this we have to find out from their analysis, correct? So you can see that frequency when it is greater than 30 in a gap of 2 months time, correct? So they are under one category, and other category says that those where frequency is less than 30 in a 2 month period, then they are. So here you can see this is the around 10%, and here it is around 84% of the required inventory is covered by only this 10% of the raw material actually. So this was the one very rough finding that we found out, and you can see that mean order amount for over 1 ton is common actually, that you can see. So this is mean order quantity. So based on this, next level of analysis says that what we did, here our objective is to predict the amount of material type required in the next 2 months in the amount of kgs of the different raw materials. And these predictions will help in reducing the lead time by allowing that pre-ordering, and the wastage of material will also reduce, as you can see. And then based on that, actually you can see the required materials can be stored, allowing better utilization of the space. And say for example, here we call Vx A1 material type, then these are the different material under this category. Like say another material type is AC, and this is the different material category within that. And these are the codes luckily which they have designed for their ERP, and based on that they classify them actually. And if you see here, then we have seen that for a combination of customers and order type, number of orders throughout 8 years of 6975 combination is below 10, and around 347 is above 50. That shows that how this varies, and these are the different you can say amount of the material type which are being ordered for the system. And the mean number of material type per customer is around 96, and with a total of over 6,000. So you will be surprised to know they are in business since last so many years, but this basic analysis which we did from their data, this itself was not fully known to them. Their, you can say, material type customer is around only 96, and with a total over of 6,000 that they are having. And then some features engineering we did here, like say customer demand and time step demand, like 2 month time that we mentioned. Then we extracted the features, like say the different kind of demand patterns and different situations, and also the what you call the other numbers. Then we found that these are the different feature importance that we attach with them. So you can see this is the demand 3 within top 2 month period is high, like say 776 type bubble time number. So that's so that this is the most important kind of thing for them. And based on that, actually, if you see the material type mean demand and for different material that we have seen, and this color you can clearly see what they stand for. Like say this color is for XA material, and their requirement is very clearly mentioned in the amount actually. So, and here you can see same way like material type frequency, that identifying the high frequency orders, that by size of the balls you can see that how much where is there is a high type of ordering we have to do based on this. So then we have applied this all the feature engineering and mean demand in 2 months interval, position of the interval in a year to capture the seasonal trends also we have seen, and then importance of past data is also applied using the lag features and rolling means actually. So from here you can see year-wise details, and this is the material type is how they are there, like with respect to their demand. You can see from these color codes, and then we found that on this side, as you can see, that average that comes out to be somewhere like here, that is the optimal frequency point capturing the maximal demand with high frequency. So this we have noted, and accordingly the analysis has been carried out. And here you can see the algorithm that we have used for predictions is the say, light gradient boosting machine, and it is a regression tree method which applies the gradient boosting and exclusive feature bundling. And then forecast period, here the major inventory material types and they are required for period 2020 and 2021 is taken into account. And then these are the variations of the predictions you can see and actual for different years. Some are actually has some prediction is like this. And forecast plots for material type with mean order of over 10 ton is shown here. So material type XAR, you can see what is the prediction and what is the actual actually. And similarly, other materials also we have shown. And these are the different demand predictions of the materials actually. And for each year also we are showing how this varies actually, and also forecasting what may be there for this. Then forecast period for major inventory material types and their required amount of period to 2020 now we consider, and then plots for material type with mean order over you can say 10 tons from 2019 to 20. If you take into account, then you can see the variations like how the actual and predicted values in each year varies actually. For this material, say SE 100R. Similarly, for XA 100R, this is the predictions actually and the actual value that they vary. And then inventory predictions that we did for different materials, as you can see that for this one XAR, as this color, you can see 7.9%. Similarly, for all other materials also, we did these predictions, and this is a table that shows that each amount of material then covering at least 50% inventory is shown like this. So this is helping the company a lot actually, because they get the information for each material and their you can say total amount of required in say year 2021 of inventory predictions. So it lead to better forecast of material type requirements and significantly minimize their lead time. And this also results in saving the inventory space by allocating other material in the space created. And order management and inventory planning are focused because no machine capacity constraints are violated. And implementation of decision tree model for the customer selection for order management and inventory planning for forecasting raw materials have been one of the red features of this. So after this example, which I have shown you about the inventory planning for a company which is more than 600 items, now we are describing you in a small nutshell another example where we have used the machine learning techniques that you can see that these are the baggage handling systems where we expect that consumers' expectation and you can say this baggage constitute a significant amount of airlines budget and capital. And this problem here, their main aim is to minimize the downtime of the both hoist and conveyors and their minimum maintenance cost and increase in service level. This maintenance activity, you can see this run to failure maintenance, preventive maintenance, and predictive maintenance that they are consuming. So with this kind of problem, it's a live problem, I can tell you, but I am sorry that because of, again, NDA clause, we cannot name the company for which we have done it. And one of my students doing PhD with me has joined this company itself already for carrying out their job, and another one is just completing here, and I will later on request him to come and explain some of the critical observation point. As you can see here, this is the host and this is the shuttle. And I have seen that how the materials are stored, this item coming, they are being sent to the shuttle and somewhere they are parked, and whenever their time comes, then they will be called to the different belts for to be taken by the customers. As you can see, there are the say yes conveyor 1 and this conveyor 2, and then for recording the different kind of data, we have accelerometer, which is here, and vibrations are being recorded here, and temperature is also somehow recorded. I will show you. These are the different sensors through which we record the vibrations. And this repeater is there through which we accelerate, we amplify the signals that are coming. And because these are the meters, means up to this 8 meter, you can see the repeater we put so that it can come to the base station where analysis is being carried out actually. So this way, the whole setup actually of different, you can say, sensors and accelerometers are used to connect collect the data. And then I think you can see that this simple dashboard which is there, that how the sensor status, then at different systems like say network interface, MAC address, PAN address, and wake up interval of 2 minutes. Means every 2 minutes we have to collect data from them. And then system information is why how the firmware and then hardware systems and temperature at that time. And then if you reboot, then what will happen? And then power at that time. And then you can say MES vibration setup, that is rate, samples, and there you can say axis, X, Y, Z, which one is there, and then capture the relevant details about this, and then vibration download, that is perfect, high pass, download, threshold values, and keep on this doing this analysis. And these are the different sensors name code they have given here. And here you can see this the vibration which varies, say root mean square velocity actually of the acceleration, that velocity that is shown here is given. This is the variation with respect to the time which is shown here. And sometimes you can see that this peak and crest here. And on this graph also we are showing same thing, that is the how it varies with respect to them. And here the 3D graph, that is X, Y, Z both we see, and then we can clearly see that in which directions it is more. And this is the where for date wise you can see. So if you put the past and later this date, suppose you choose a date 18 here, then you can easily know that on date 18 what are these data, and then accordingly you can get the information for building a time series model for the predictions. And then after that, the whole digitization model works something like this, that we have sensors here, and then this is used for data acquisition systems, then base station. And there are many edge computers are connected with that. And then there is an open source platform where they are doing the analysis, and then their data centers. And this was the cloud server through which all these things are passed for the analysis. And this is the one setup that they have followed. And then kind of data analysis they have done, like how the past Fourier series they have applied to sort out the data and clean the data, and how the high RMS value, low kurtosis value has been eliminated, and accordingly whole analysis with respect to the time and amplitude of the vibrations they received. This has been done. And as you can see that peak and peak to the voltage, this has been mentioned, and these are the different relationship that has been shown. And based on that, actually, you can see the flow chart of the analysis, the raw data, the data cleaning, and time domain analysis, and the frequency domain analysis, that is extracting different kind of features. Then historical data for training. And also here you can see the learning algorithms, maybe supervised, or these are the different algorithms that people are using. And then trained models here. And after that, you have to say evaluate the features. And from here, you can make the predictions. And this side also for new data, data cleaning, then extracting features, and again evaluate the features and then make predictions. So this is the simple methodology being followed here. Now, since this has been done by one of my students, unfortunately, who is here with me, so I am asking him to explain that how he has conducted the experiment, and then come out up with the recommendations. Just within 2 minutes, he will explain to you. Roni, please. He is Mr. Roni Mitra from Maths and Computing Department of IIT Kharagpur, and he is with me. And then now he is actually one of the students involved in this project.
This is the dashboard where a engineer, without going to field, from a room, he can analyze the equipment, and it's when equipment going to fail. So from this, these are the sensors. There are 29 sensors. So if we craft this sensor in terms of absolute crest acceleration and RMS. Now if you click one of the sensor, you can see that this is the prediction graph, where we can say that actually we are not much data is available with us at that time. So we can say that here the equipment is going to fail. So for that, some maintenance activity was done by the engineers, and after that, after certain amount of time and some maintenance activity, the equipment is going to run accordingly. And it is from here we can say that after comparing the historical data, we can say that our prediction model is run quite better. So for that, we also, before doing this, we also clean our data by using some FFT and inverse FFT. And after that, we delete RMS value of the data, of the data less than, if the RMS value is less than 0.4, we delete the, if RMS value is greater than 0. Less than 0.4, we take this for our analysis, and if kurtosis is greater than 25, we consider those type of data for our analysis, and by using those data, we use this, and this is the final prediction model, and we compare this prediction, our prediction model, with the maintenance activity, historical maintenance activity. Now it's over to Professor Tiwari.
So finally, I can say that this project lead to the vibration sensors, which collect vibration data from the machines, and then it is processed and compiled with the historical maintenance data. Basically, random forest has been used to make a real-time decision whether the machine or its equipment are safe to operate. And then these findings are based on the indoor testing without going on the field to check machine conditions. And finally, allocation sensor installation, which is costly, but predicting machine failure in advance give a lot of leverage to the firm, particularly downtime, labor hours, and other measures to enhance the productivity. Actually. So with this, there are, I can say, for such kind of things, we found that there are statistical modeling schemes, the machine learning schemes, as you see, data mining schemes, and data visualization through different type of plots and what you call Python Seaborn. And all these tools are being practiced now by our group actually to see. And finally, I can conclude that there are many areas where the attention of the experts are invited actually to address either this prediction problem or kind of you can say mix of the both optimization as well as this because we are just running a course with Professor David Simchi Levy, where he has very nicely explained that any contemporary analytics in the business as well as in operations requires the judicious mix of both actually to come out of with proper recommendation systems, which may lead to the better productivity improvement. So with this note, Rahul, I just conclude my talk, and now over to you actually.
Thank you, Professor Tiwari, for such a nice presentation. I learned a lot about very, very cool and innovative applications of data science, visualization, and also machine learning. So with that, we come to our question and answer portion of the seminar, and we have close to 4 minutes left. There is one technical question from the audience. I think this is basically a sort of awareness or question, which is what is predictive maintenance?
And you know that when I talk about predictive maintenance, then it will take the many operational data, and accordingly, it may be able to see that, okay, at different, you can say, load conditions and others, then what kind of precautions we should take to replace the equipment or go for some overhauling activities, or you can take some precautionary measures to avoid failure, which is very costly for such a, say for example, the airlines operation Rahul. I have seen the hazard when the belt is not in operations, correct? And then if you ask the people to rush to another belt, then you have seen that what if things are happening. So here predictive maintenance is very, very important because this gives you an idea that in advance, if you knowing the past history, you can easily know that, okay, this is the thing, and accordingly you can build a maintenance schedule also. Okay, these are the critical things that we need to set it in proper place before every time that any failure may take place.
Thank you, Professor Tiwari, for explaining. Um, we have an audience which is primarily comprised of students and industry practitioners. So we have some general questions also. One of the questions that I ask generally of my panelists is, you have been in this domain. What are according to you, some of the good attributes for a person who is interested in becoming a good data scientist? What attributes should they have?
Actually, when you ask this question, then I just see that what are the people whom I know and they are working as a data scientist. I can say that one of the things they must know basically, you know, that they should have very good knowledge of the AIML coding, Python language, and very good comprehension and of statistics. Actually, I feel also very important. And some of the people whom I know very well, they are very good data scientists at present, and they all have this you can say training and learning since the beginning. So I found that those who have very good background of the statistics and data structure coding, particularly nowadays these new algorithms. So if, I take my own example, Rahul, when I used to train my students, then many of them used to code in the C, C++ at that time, and today most of them are working in this domain, and they are in the very good companies and they are doing excellent work because that background is helping them. So this is, you can say, is the real boon period for all those who are analytically very sound with respect to different kind of modeling techniques, and those who have very good coding skill, particularly on this newer side. And recently a lot of softwares has come up where this has also minimized your burden of the coding because already many of the things are inbuilt there, and only you know that how to handle the data and how to clean the data, and accordingly you go ahead with the some sort of thing. So this is what I've seen the transformation in the area, that where there is a also focus on the knowing more on computer science, but now you have to know more on the problem structure and how to really simplify it so that it can fit into the some sort of well-known tools.
Thank you very much. There is one last question. This is a technical question from Abhay. He says that we see a lot of use of machine learning in supply chain, but oh, sorry. One of the things that he's concerned about is biggest challenges in tendering process. Right. Right now, most of the tendering process is based on current costing, so you can do some forecasting on that. But what happens if you have to do tendering where the fulfillment date is 2 to 5 years in the future? So any tools analysis, if you can recommend to him for such a problem where the forecasting is of 2 to 5 years down the lane, how do you go about it?
Actually, Rahul, this question is mostly, in my view, goes to the project analytics, because you know very well when you apply both the techniques, like one was the which is totally deterministic and one is the totally you can say probabilistic. But now add into that and all this stochastic phenomenon also. So I can say that knowing the tendering process and also the complexity involved in the business. Say, for example, those who are involved in the construction activity, then what are the problems they face in resource sharing, particularly costly resource sharing. And this happens when they have many projects going on side by side. So question is that at what stage actually you require those kind of sharing arrangements, and then how to basically make rationing of them, what kind of model you are going, cooperative models, so that both the projects should not go overrun and they should also come to the time. So I can say that project analytics techniques based on the past history of the equipment and people, those who are involved, and also like say it depends on the experience also they are having. Suppose you have handled the refinery project, then you can also handle similar kind of other project which requires same type of thing. But the experience of refinery is not good for experience in the road construction. Actually. So idea is this. So whatever experience you have noted, what are the criticalities you have noted, and based on that, now you can apply these prediction techniques to see that these are the time or critical domains where you require the prediction methods, particularly number of people. Say for example, let's take India. Here I know very well the moment this festival season comes, there is a shortage of the labor actually. So suppose you are doing some activity, construction activity, and you have timeline ahead before you. So if you have not planned that how much you are going to do in the month of say October when there is a all puja season comes up, then I can say that project manager is not very efficient person because he should have taken all those factors into account. How many people he can get for doing this kind of job. Similarly, I was doing very interesting problem, Rahul, with respect to the currency forecasting. As you know very well, in our system, there are different denomination of the notes, like say 5 rupees note, 10 rupees note, 100 rupees note, 50 rupees note, like this were there. And while doing that, the bank has asked us at the chest level, not at the branch level, at the chest level, how much each currency type should be there. And then we applied all these Harima models and other things based on the past history data. And we predicted that, okay, per day, how much, say, 5 rupees note would be there in your bank, how much 10 rupees note should be there in the bank, and also consumption pattern, that how it was consumed in same type of things last year. So, but this consumption pattern is totally different in different states. Like say, when you talk about the Bengal, then at that time, puja time, there will be high consumption. If you go to the north side, during the marriage portions, then 20 rupees, 50 rupees, 100 rupees notes are more consumption. So like this whole thing we consider and then came out of with our recommendations. Each month, each week, how much actually these demands of the rupees should be there. Similarly, in project also, you know very well it's labor intensive projects or technical tech oriented projects or software projects. So which are the area where actually you need more critical things? Based on the data, you can also find out that how things can be predicted and accordingly corrective measures can be taken.
Thank you very much, Professor Tiwari, for your answer. With this, we will conclude this webinar. But before I end, I really personally want to thank Professor Tiwari and also Dr. Dolgui for spending their very, very valuable time with this broad audience where we are trying to basically create an outreach community where we are educating everyone about applications of data science, machine learning, AI. And today we talked about exciting applications in supply chain and management. With that, we will stop. And again, with respect to the information about next webinar, I will be basically posting them on my Facebook and my LinkedIn profile soon. Thank you and have a great remaining of the day.
Thank you. Thank you much, Rahul, very much. Take care. And to all the participants, namaskar. Thank you very much.
Thank you.
Thank you.